Which one do you want to look at? Which one? 15.
There's a couple little tricks to recognize when you are shifted or not. One of the easy ways to tell if you are shifted vertically is, remember, you're not going to have any horizontal shifts with any. No H's in when I give you graphs or ordered pairs. When you look at something like this, notice how your y values for your maximum and your minimum, they don't have the same absolute value. Everybody see that? That right there tells you that there's been a vertical shift. So in order to figure what the vertical shift was, we're going to find the midpoint of the y values. What's the halfway point of -2 and -6? -4. That means that it's been shifted from the origin down 4. So now there's a new, imaginary, if you will, new origin line at a k value of -4. It's shifted down. So if I'm looking at that, cosine or sine starts at either a maximum or a minimum. Which one starts as a maximum or minimum? It's cosine. So we know that this one has to be a cosine because it starts at a maximum. So we know it's a cosine. Now, since it started at a maximum, is the a value be positive or negative? Positive. It's going to be positive, so a is positive. How far up is it from our midpoint? 2. So your a value is positive 2. Now we just figure out our b value. Our b value is going to be the horizontal distance between excuse me, not b value. We're going to find half the period and double. And half the period is the horizontal distance between your maximum and minimum. How far is it from 0 to 2? 2. So half of our period is 2. I double it to get our period. Our period value is 4. I set that equal to 2 pi over b. What's b?
Pi over 2.
Very good. b is pi over 2 in this case. We now have a, b, and a k put in. Normally, since there's no h values, I'm not going to write anything in parentheses, and our k value is negative, I'm just going to put it in front. It's no big deal if you unpack it later on. So it's -4 plus 2 cosine pi over 2 x. And there's your equation. It's the easiest thing to do is just to kind of identify right off the bat if there's a k. If there's a k, then you work off that to figure out a's and b's, or the a value, obviously. Right. Does that make sense on that?
Do you have any little tricks to tell me sine and cosine when it's shifted?
It's the same. What's that? The easiest way to tell if it's sine or cosine, even if it's shifted or not, is once you figure out if it's been moved up or down. When you draw the line through, since we're starting everything at the vertical, if this line, I'll get you one second. If this line touches the graph 3 times, sine. If it doesn't, cosine.
Between 2 tick marks?
Well, between a full cycle. Because you'll see how it starts, it's got to come back up. If it touches it twice, it's got to be cosine. Whereas if it touched it, if I can do this, shifted 90 degrees, where it'd be.
I understand.
But yeah, you see what I really don't know what I'm doing. But that's okay. Mr. Zach.
So to determine the shift or the k value, you apply the midpoint of the maximum and minimum?
Yep. Easiest way to do it. Really know that's the easiest way I could think of in a heartbeat to do it. Yes, ma'am.
So how do you tell if something is positive?
Once you identify where your k value is, that's the easy part, right? Is your starting point above it, or is it below it?
So like below it is negative?
Correct. Okay. So if I look at the other one that had the shift on 14, but look at this one. Notice how, again, they don't have the same, and this is what you were about to ask me a second about the k value. Notice it? What's that? That's what I'm showing you again. Re-showing. Notice the y coordinates of the maximum and the minimum don't have the same absolute value. Okay? What's the midpoint? What's your k value? There's your midpoint. It's a sine graph. It's a sine graph because you look at it, it starts at the vertical axis, goes to the maximum, then it goes to the minimum. So it starts here, goes up, then down. So you know that this has to be sine. So it's got to be a sine graph. Also because within one cycle, it hits it 3 times. Okay? So if your k value is 1, because it's been moved up 1, your maximum, it goes to its maximum, so it means your a value is going to be positive. What's your a value? 1. What is the distance between 1/4 and 3/4? Half. So I take 1/2, I double it, and that's my period. So my period for this graph is 1. I set that equal to 2 pi over b to find the b value, which is
2 pi.
There you go. So b is 2 pi. So your final answer would be y equals,
Sine 2 pi x plus 1.
yeah, 1 plus sine 2 pi x, and that's fine. Or sine 2 pi x plus 1. Either way is perfectly fine. Usually if there's no h value, I put it out. It's just any variance. A gazillion. It is, but a gazillion is more than 7 billion. So you're going to be negative a gazillion minus 7
How
billion.
many zeros does a gazillion have?
I don't know. Why don't you find out?
I don't have any.
Google is 100.
How many zeros is a gazillion?
It's not even a real number, Jenny. He's joking. Oh my god.
It has not,
It's not a real number. There's 100 zeros.
Can we have a Brazilian too?
it's either 12 or 9.
What was that, Thomas?
Can we just bring up
a million.
I get shot by a nurse. I can't
It's
get
6.
it.
What? Billion.
I can't
Take a look at this. Is there a k value? Why is there not a k value here? I'm going to take a look. Y coordinate is -4, the other one's +4. Do they have the same absolute value? That's how you know there's no k value.
Then how do you know if it's just like
Where does this one start? If you go back to the axis, where does it start? Does it start at the origin, or does it start at maximum or minimum? It started at the origin via its k shift. Yeah, it started at shift, and that's fine. Does this start at, we've already identified that there's no k value. So this one's either going to start at the origin or a maximum minimum. Which one is it? That starts at the minimum, so therefore what graph is it? Cosine. So this has to be cosine. Since it starts at a minimum, is your a value positive or negative?
Negative.
Negative. So your a value is negative. Negative what?
4.
Good. How far apart is 0 and 1?
1,
Double it, what do you get?
2.
So your period here is 2, so you said equal to 2 pi over b. b is? How are you?
That was bad.
So are we done?
Yeah, just fill in the blanks.
That's a swell rock.
Go to bed.
I appreciate it.
Yes, yes. We'll protect him. I've got the 8 areas of death.
He's got a tip list.
Shattered a
That's not.
Well, I found the golden ball on the football field once, so
No,
I said tip list.
this thing is probably 30 some odd years old, 40 years old maybe.
Just like the
Grip, I don't
intruder.
want to swing this too much because I think the grip is just going to fall
Just
off.
like the intruder will be.
What?
Yeah, the intruder's the same as the golf. It's a metaphor, isn't it?
No. That was a bad joke.
Intruder! I was worried for someone about to come out after you.
So creepy.
Save it. What else do I look at?
You can just like grab it out of there. Like, in the open
Stop that.
matrix. It's part of a plan because I insulted Zach for the first half of the year. I'm complimenting him to be a nice person.
No, because we didn't spend that much time on it. I'm not gonna worry about the basic stuff. I do want to show you one other part of 14.5 real quick.
No, don't do it as a plan, just be nice.
I know, okay. Stuck on the floor and I'm kind of sad someone like these things in the book, but I don't know if you want to throw it out.
I don't really need it, but thanks. It makes good earrings. Or a cool necklace.
I would say a necklace.
The last little bit of this is writing the functions given just a set of ordered pairs. So let me show you a few of these.
We write these in the notes for the homework.
Just leave it with the notes. Remind me to get back to that homework too from past days. I've got a couple extra things to look at. Because after all, I'm done with these few and we're done with this intruder thing. I'll go over a whole bunch of stuff from what we have to do. Okay? So here's what happens. The last little bit of this will be writing the function write the function for a sinusoid given a maximum at point A and a minimum at point B. So you know your maximum minimum. The only thing that's different here is you don't see the graph. So here's what we do. We can, and that's what I like to do with a lot of this. So we have a max here and a minimum here. So I just start it out and plot. H and K. There's no H, but there can be K's. And you'll see how it works. It's pretty easy.
Why are there no H's?
Like I said yesterday, a sine graph is just a 90-degree shifted cosine. And a cosine graph is just a 90-degree shifted sine. Do you remember that? I think you even mentioned the fact when I drew those two curves here, it looked like a slide.
I said that.
Yeah.
Somebody.
It looked like a slide.
It did not look like a slide.
It did look like a slide.
Yeah, that's right. That's why we don't bother with the H's.
So you don't know.
Your calculator that does a sine regression with an H value on it, when you do your table stuff, it just presses a button and it does it, so you don't have to worry about it. Here, if I plot my maximum at 0.3, and my minimum at, well, here's 1 pi, here's 2 pi. Here, that means it's doing this. If it starts at a maximum, what graph is it? Cosine. Notice that your ordered pairs, your y values are at 3 and -3. Is there a vertical shift to this? No, there's no k value. You have a cosine function. Is your a value positive or negative?
Positive.
Why is that? It starts at a max, so your a value is equal to? Now the last thing to do then is figure out our b value. How far apart horizontally is 0 and 2 pi? Double it, you get? So your period is equal to 4 pi. Set that equal to 2 pi over b, and b is? Very good. And you can put the rest together. Right? Do the other two.
Sure.
I found out throughout the day today that most people like it when they're just given as the ordered pairs.
Divide by half.
On the first one here, do the y coordinates have the same absolute value?
Yes.
Is there a vertical shift then?
No.
No. So we go ahead and plot to get a kind of a rough idea of what it looks like. Pi, 3 pi, it goes to 8, down to -8. So if it doesn't start on the axis at its maximum, it has to get to its maximum. Is it a sine or a cosine? Good. So this is a sine graph. Because it starts at the origin, goes up, and comes down. That means that your a value is what? 8. Good. Your 8 is an a value. It's positive because it goes to the maximum first. What is the distance between pi and 3 pi? Double it. So your period is 4 pi. Set that equal to 2 pi over b. What is b again? B is 1/2. So your final equation, how?
Yes, I'm confused.
Multiply by b divided by 4 pi. What's 2 pi divided by 4 pi?
Half.
There's your b. So you get y equals 8 sine 1/2 x.
I got it.
All right. And then the last one has that little vertical shift to it. So we have that vertical shift to it. What I want you to notice here is when you plot it, you've got a maximum at 9 pi and 1, and a minimum at 3 pi and what's that? Yeah, well, that's the only reason why we can't have this on Tuesday or anything really next week, because Park comes back next week.
It's a party in the park.
Yeah, yes, you will get your schedules from the park tomorrow. It's going to be basically 2 half days. Yes, sir.
What if you're not going to be here?
You're going to have to make it up. They're going to pull you out of a day of school after you've been gone so you can make up your park test.
No, tomorrow. I don't get the schedule.
You'll get it on Monday.
Is there the same conversion?
No, it's totally different. Yes, sir.
Can I request for it to be gray with green this time? Because I didn't
Too late.
have time. Too late? Are you kidding me? Take it, don't
They're doing
next
it
year.
differently this time around, like doing it like one at a time.
I don't. There's one less test, that's why.
I need to see it.
It eventually, who knows? I wouldn't want it. I would believe it would.
Special mouse too.
All right, anyway, notice this one here that you have, guys. Notice you have a vertical component because your y values are different. What is the midpoint of the 2 y values? This was just -2. The midpoint is -2. So if the midpoint is -2, that means that you've got a k value of -2. Now, notice that it goes to the minimum after it's off the axis. So that means this is what kind of a graph? Sine graph. You know it's got to be a sine graph. It's got to go from here down to here, eventually back up to there. How far is that minimum from that shift? 3. Did you go up or down? So it means your A value is? Now how far apart is 3 pi and 9 pi? Double it. So your period is? Oh, yeah, I'm sorry, yes. I knew where you were going with that. So your B value is 1/6. Yeah.
Why is it signed in?
Why is it signed again? Notice how your maximum or your minimum is not on the axis. That means sine.
So
If
if
you
it was
s-
on the axis, then it would be.
Cosine. Yep. Try these two. In the first one. First one, you have pi over 3 and maximum at pi over 3 and a minimum at 0, 2. So you have a minimum at 0 and 2 and a maximum at pi over 3 and 4. So if your minimum was here, your maximum's here, what happened? Shifted. Where did it shift? Up. How much did it shift up? 3. Shifted up 3 because if this is your maximum, this is your minimum, what's halfway between 2 and 4? 3. So there's your new origin, if you will. So your A value, since you know that it starts at a minimum, your A value is going to be negative. What's your A? -1. Is this a cosine or a sine graph?
it's cosine because it starts at a minimum. Now we have to figure out how far apart is 0 and pi over 3. Pi over 3. Double it, you get? What's your b value? 3. And your k value, we figured it moved up 3. So your equation would be 3 plus, 3 minus cosine of 3x. Why is it negative? Because we started at a minimum value, moved up. Bless you. It's always easier to find that k value first. It's a lot quicker, a lot cleaner. And 22.
Basically, after you find the k value, you subtract it to find the original point.
Yeah, it's kind of an easy way to do it.
Call it 3.
Here we have maximum 2 pi over 3 and 9, minimum at 2 pi and 5. So if your maximum is up at 2 pi and 9, your minimum, or excuse me, 2 pi over 3, and your minimum is at 2 pi and 5. What's halfway between 9 and 5? 7. So your k value here is 7.
So basically, your value 2.
Correct. So k is 7. Your a value is 2. Is it a sine or a cosine graph? And why is that?
This is only a test. This is a drill. Again, this is
Midpoint of your y values, that's your k. That's your shift. From there, when you draw it in, it's pretty easy. How far is 9 from 7? 2. Did it go up or down? So is your a positive or negative? Positive. So how far apart now is 2 pi and 2 pi over 3?
4 pi over 3. They said 8 pi over 3.
Yeah, so you have, this becomes, what is that, 6 pi over 3? So yeah, 4 pi over 3. So the distance between the two is 4 pi over 3.
So is that all twice?
Double it,
8 pi.
and you get 8 pi over 3.
I'll say log.
You set that equal to your 8 pi over 3 has to equal 2 pi over b. So you multiply by b, divide by 8 pi, multiply by 3. So what does that become? 3/4. So your b value is 3/4. Okay? Just takes a little bit or two longer when you have some of the fractions.
Get my own jokes.
And so you do the cross multiply to find it.
Yep. All right. Now, the questions that people have been asking then, as far as what's going to be on the test. Sections 2-5, scatter plots. Boy, that was tough.
That was just all calculated.
Scatter plots, basically what you're looking at in that section was were they increasing or decreasing. That's it. It was very, very simple. We didn't spend a whole lot of time. After that, we jumped into, well, actually before that, pardon me, was 3-4. That was that linear programming. Your word problem. Shading to find the feasible region. Going through all the paperwork and everything that I had, I found 3 problems that we have not done yet, so everybody gets one. Yay! Okay.
Like, every class gets one. Classes?
Yeah.
Gonna be like a work color.
Yeah, just like we were doing before. So-and-so has so many of this, so many, you have this, you have a profit of this, and that, of that. Yes, ma'am. You guys get one. Each class gets their own. No, you haven't seen these. I've shown you every, I gotta save them. I have to hold on to a couple so I can use them for quizzes or
Where do you
tests.
get them from?
I make them up. Because I had 3 that I haven't used yet. And the last
It's like
one.
bad jokes, like you guys get stuck.
No, if you think about it, we did, what, 15, 20 of them or so?
But like, if
because you have a whole bunch of them already. Yeah. Well, oh, yeah. Here, let me get the test out so I can read you what you're going to have tomorrow. We'll do that one.
Please. Oh my God.
That's right. Okay. After that, we did the scatter plots, then we went into 5-9, I think. That was your quadratic regression. When we did the quadratic regression, it was just real basic curve stuff. I did give you guys some problems that dealt with 3x3 systems of equations. Then I showed you briefly how to use a matrix. I'm not giving you anything with the matrix on it, because we didn't spend a lot of time in assessing how to do that. Okay. Knowing something is quadratic regression is pretty easy. It's going up, coming down, and one change of direction within the set of values. The other two are strictly increasing or strictly decreasing. Then we got into polynomials. Polynomials is where things got cool. I think it was 6.9 polynomial stuff. When we were talking about polynomial regression, we were talking about identifying whether or not it was a cubic, quartic, fifth degree, fourth degree, second degree, whatever. By using that, the lists, the tables, by looking at the finite differences. Remember when we subtracted and found Satan every time?
Yeah.
Then we were able to tell by how many times we had to subtract, we were able to figure out what the degree of the polynomial was, use their list values in the calculator, and hit calculate, third degree, fourth degree, whatever it might have been. Really, really straightforward. We also did write out the equation of a polynomial given 3 sets of ordered pairs, where you had 3 intercepts and a point. All you did was find A. Okay.
You had to simplify inside the parentheses, multiply, and divide.
Yep. Yeah, it was really easy, but we did it. Yes, sir.
Was it for the quiz game time?
Yes, sir. After that, we jumped. Yeah.
You said that for we'll have the polynomial where we have to find the 666 thing, and they'll be you won't tell us those are the problems we're doing. We'll have to figure it out.
You'll see it. I'll give you a table, or I'll give you something like that, and I'll say, hey, write the equation of the model of this data set.
Okay. And will there be decimals in the mix?
Maybe.
Okay. That's fine.
Okay.
Is it gonna be all, is it gonna be calculated, not calculated?
It's all calculated.
Oh my gosh.
Then we did 8-7? Yeah, because there was no 7. So we did 8-7. That was the logistic. No, that was exponential. The exponential, we'll talk about exponential graphs. Those were ones that were increasing at an increasing rate. Each time they were increasing more and more and more and more and more. All right, that's how you're able to tell it's exponential. Also, when you looked at it graphically via your lists, if your original curve was like that, what did the natural log curve look like? It looked linear-ish. So that was one way to prove that something was exponential, because you could take the natural log of a list and redraw what that would look like linear. So if they were close to being linear, then you would know to press the button in your calculator that said expo reg, or x reg, I believe. Right.
I'm curious, you only found the exponential function, but I have some friends in the algebra.
There's no reason to do, we don't do power. There's no reason to do power functions. There's no.
Yeah, 'cause I know that they learned it.
Yeah, there's no reason to. There's absolutely no reason. In the other one here, then we wrote out the equations where y equals ab to the x. I gave you 2 ordered pairs of an exponential function. You're able to substitute in, solve for x, or solve for a, solve for b, rewrite the equation. Pretty easy. Let's see. After that, you were introduced to good old-fashioned logistic growth. And that was the one that had constantly increasing from left to right, but it had that maximum growth rate value. It had a pair of asymptotes. One was at the numerator, that C value. The other one was always at 0. And then that maximum growth rate, that's the only thing you really had to know about how to solve for that. And that had that weird ordered pair for the max growth rate. The natural log of A over your rate, comma C over 2. That gave you your growth rate value. Where does it occur? Okay. We also did some of those logistic ones where you were able to solve for x. Remember, I had you solve a couple of those for x, or where it said equal to something, you had to do a whole bunch of 9 steps. It wasn't that bad. In order, yes, ma'am. No. When you're looking at the logistic graph, being able to identify that instead of it being a cubic graph, remember, the logistic graph has a ceiling to it. It's capped by an asymptote. Same thing with the, its floor. There's an asymptote below that. Whereas a cubic function will always be increasing or decreasing depending upon the tails. It's just the change of direction in the middle. This one just changes direction halfway through. It quickly changes direction, then it slowly changes direction. All right, it's still increasing. It's increasing at a slower rate. Also, the logistic one. What's the other thing we did with that? When we use that one via like a model, when you're looking at like a word problem-ish, what was it always kind of associated with? Population. It was population boom, things like that. That was pretty evident that that meant it was going to be logistic. Okay. And then after that, we did 14.5, right?
Yes.
So in 14.5 was the last little bit. We've been spending a couple days on that. The only thing I didn't show you guys with 14.5 is how would you press the buttons in a graph on your calculator to find if it was a sinusoid regression.
SINREG?
Yeah, SINREG. That's the button in your calculator that says SINREG. If it looks like it,
COSREG?
no, because it'll calculate it. What the calculator does is the calculator will find the SINREG, the sinusoid regression. It will give it an H value. It will put it only in terms of sine, and it will shift it. So it doesn't look at it via sine or cosine like we are with just the 2 points. It takes a shift into account just by looking at the sine value. You don't need to know how to do all that. It's pressing a button on a calculator. So if you get a table, you get something like that that looks like it's a repetitive setup, you know it's a sinusoid graph. You'd hit SINREG. Okay? It's one of the buttons on the calculator. Yes, ma'am?
Which graph calculator is the one where like, you can choose which graph to use?
Stat calculator.
No, it's not that.
The stat plot, that's y equals.
Oh, for the stat plot? Oh, I know what you're talking about. How to connect them?
Oh, there we go, yeah.
Yeah, that's at second y equals, and then you choose your plots and stuff like that.
I just figured out where it was.
I usually use the second next to the dots. Other than that, could you tell what a graph looks like? What kind of a graph is this?
Exponential. Wait, no,
Linear. Which is? Quadratic.
Oh, I hate that word.
Cubic. Fourth, so that'd be, actually this is fifth degree, I drew it poorly.
It's a weird name. It's not-
So this, yeah, quintic, but this, I don't think we ever did that, so. There, quartic. Try it. It's fun to say, sinusoid. Logistic is just. That's all I had. I expected to be doing this all the way to the bell, but we got to use flex instead. What's that, Tom?
do you have your
I don't have any.